I'll check it out. Yep.
Okay.
Okay.
Awesome. Okay. Everybody, we are going to be talking today about the HUNCH Design and Prototype website and the projects that are going to be happening this year for the 2018-2019 school year. I'm just going to give a very quick rundown of the website and the kinds of things that you can find on the website to help you through your projects, and then Glenn Johnson will be going into more detailed discussion on the projects that we have. So as you can see here, I'm on the home site, which is just hunchdesign.com. And if you go into the home tab, you'll see that we have kickoff videos, helpful links, expectations, information about talent authorization forms, and material order sheets. And this very first page gives a little bit of information about HUNCH. It also gives you the link for the Google map of the International Space Station, which can be very helpful as you're working on design projects that can take you through the International Space Station. The kickoff videos are just to give you some information about HUNCH and about our program. The really, another important area is this helpful links page. It's going to give you information about space station tours, space station layout, living in space, all of these different information, which is really good for your preliminary research, because as you start to design something for a microgravity environment, it's very different than designing something for a gravity-based environment like we're used to. So these links can help you to understand what it's like to be in the microgravity environment and how it might potentially affect some of your designs. When we go into expectations over here, we talk about this research on microgravity, and we actually have like a document that can give you some questions to answer about research in microgravity. We also talk about our web conference expectations, because all the mentors are spread out across the country, and so most of our interaction may be by web conferencing. And then we talk about our preliminary design review expectations and critical design review expectations, as well as our Houston final review for the top projects and those expectations there. So really helpful information here to help you get prepared. Okay, then we go into our design and projects list, and we're going to go through that here in just a minute. But one thing that's really important is if you'll notice, there's other information as you pull down here. Okay, if you go into the project information and supporting documents page, this is to help you with your projects, give you a little bit more detail on those. These on the left are new documents for this year that pertain to this year's projects in particular. We also have documents on here from some projects that were from last year, but some of these documents, even though they're projects from last year, have valuable information on their PowerPoint presentations. So you may find good information to help you with your project based on some of these older projects. Then we also have some of our general information and drawing files, which is also really helpful information. For example, an overview about HUNCH. Everybody always asks about batteries and magnets on orbit. These documents are there. We talk about flammability being a huge issue on station, and we have information here. So there's a lot of good documents and information on here that can answer a lot of your questions. So I would definitely look at these first and see if it can answer any of the questions that you might have. Okay. Then over here, we start talking about our timelines. Every region is going to have a little bit differing timeline based on when they're going to be doing their preliminary design reviews and their critical design reviews. So make sure to look at this page to see what your area is going to be for this year. Some of these have not been updated yet, but they will be very soon, because some of our schools in the Northeast don't start until after Labor Day, and we're on August 22nd today. So then if you want to go into our current and former project updates, these are just kind of showing you some different project areas that we've done in the past, and where they've gone, and who all collaborated on them, and just giving a lot of good information about the project. So there's a lot of different projects here. Some of these have already flown, and some of these are still in work. And so it just shows you that all the projects that we work on are for the benefit of NASA, and we have a lot of contributions to the NASA community based on these projects that we work on. Okay, if you go into the more section, you'll see the winners and contenders from last year. I'm putting that up, and then hopefully we can add some good photos and videos from this year. So as you're working on your projects, if you have photos and videos, you can either attach them per if you look on the home page, our hashtag of HUNCH Design 2018, and you can tag your pictures. If you have videos you want to send those to me, or to any of your mentors, or pictures you want to send to your mentors, then we can add those onto the site as well, which is kind of fun because then you get to see what everybody is working on. So I think at this point now we're going to go into the design and prototype project list. So we're going to go to this page. Now if you notice on here as we're going through the project list, we are keeping the same software projects that we had from last year, and we are using the same video from last year describing those software projects. So those software projects are really a continuation from last year. So if you worked on these projects last year, then you're welcome to continue and refine those projects. If you've not worked on those projects but you're interested in working on them, then you can definitely start working on them this year as well. So once we get through this video today, we'll be adding that video discussion onto here. We're also going to do a separate video discussion that goes into more detail about our washing machine project that we're going to be talking about as well. So there's also one other important thing before we get started is this design and prototype project student template. It's just a guide that can help you as you're going through your project, just to kind of help you be able to get your ideas together and be able to have something that can help you through the process. So that's a good template there. Okay, so now we're going to open up our project list. Okay, and I'm going to let Glenn start talking here.
Okay. All right. Welcome, everybody. I'm really looking forward to seeing what kind of ideas you guys come up with for these projects. I think we've got some really exciting projects, not just because of the projects themselves, but also because these are no longer just for the International Space Station. We are also looking forward at some of the new vehicles that NASA is developing and other companies. So these are further reaching potentially than just the International Space Station. So I think that's pretty exciting. Allie, could you give me the next page? Okay, and so here we have some more links. This will help you with understanding the zero-G environment, as well as understanding the space station and what kind of work they do up there. So there are some terrific tours for the space station, videos that astronauts have done, and videos and links to pages that are really very well done. So please check out some of these different links. I'm certain that you will have a good time learning about it. Okay, next page. And this is a little bit more general information. Same kind of thing. The Google map of the ISS is terrific. It's also fun because if you can find things that were built by HUNCH students, there are little Easter eggs to be able to find those. So check that out as well. Okay, next slide. All right, so our first project on the list is about a spare tools pouch. And so this is an interesting project just because most of you have dealt with some kind of tools, and you can imagine that if they're all stored in a Ziploc bag and they float around in front of your face, you might lose a few things. And so what had happened was several years ago they had all of these tools in drawers, but the friction fit for those drawers kind of wore out, and so they sent up some new drawers and new tools. And the crew said, we don't want to throw away the tools. Let's just get rid of the drawers and we'll hold on to all these tools. And so they put them in Ziploc bags and they put them into a cargo transfer bag, kind of a bag about this big or so. And now when the crew goes in to use some of these spare tools, some of them get lost or they float out. And so we are looking for a way to control these a little bit better. Now, on this particular slide, I have a couple of examples of the kind of tools that we have. If you go to one of our sample, to our information page that Ali showed a little bit earlier, it shows all of the tools that are on the space station. And so there are 5 drawers of hand tools. And if you go through some of the ISS tools, you'll see exactly what we're looking at. And it'll give you an idea of what kind of, how would I store these tools? And part of the idea is that if I've got a big bag and about 4 times this size, if I pull out some bags in a Ziploc bag and open that bag, just the opening of that bag is going to let those tools kind of float up. And so rather than being in a Ziploc, I would like some kind of a pouch that holds maybe all of the wrenches, and then another one for all of the sockets, and then maybe another one for all of the pliers. And the idea is that by having them in, having kind of like a little notebook, it allows I can choose which tools I need to get out without having to open up all the different pouches. And so there are a lot of different ways to do this, and so it gives you a lot of open range for it. Now the other thing is, this is really potentially this could be a soft goods engineering. So if you know somebody that knows how to sew and can help out with some of your design, I think that would be terrific. If you have a sewing team at your school, I think this would be a great one to team up with them as well. So take a look at this one. I think you'll have a lot of fun with it. I'm looking forward to seeing what kind of things we have for it. Okay, next slide. This is a very exciting one as well. So this one is specifically for going away from Earth, from being in low Earth orbit on the ISS. This is for our new spacecraft that are going to be in an orbit around the moon. And so the difficulty is that as we get further away from the Earth, we have to worry about more radiation. The Earth's magnetic field helps protect us from all of that radiation. But as we get to the moon and as we go to Mars, we're not going to have that protective shield from the Earth. And so we're looking for ways that we can protect the major organs of an astronaut, things that produce blood, that have a lot of blood in it, as well as just organs that can get damaged from radiation. And so we're not looking for some kind of battle armor like what you might see in video games or anything like that. We're really looking for armor that is going to be able to protect those inner organs. And so you can see some of the examples that we have here. It turns out, let's see, so that first picture in the upper right hand corner, that is somebody else that is doing that same kind of research to be able to protect people from radiation. And so we are looking for ways that we can shield ourselves from alpha and beta radiation, and you need to look up, make sure you understand what kind of radiation we can protect against. And to do that, we're typically doing it with a high density plastic, or we might use water, or might have some other materials. But in this particular case, we're really looking to be able to come up with some kind of a shirt, some kind of a jacket that we can be able to slip different types of radiation protection into and have the flexibility so that our astronauts will still be able to move around and be comfortable. And you might also be considering how much material I can put on this person and not be loading them up with heat, right? Because it may also get hot if you're trying to do a lot of work. You don't want to be bogged down by too much material that's going to overheat you. Okay. Thank you. This one is specifically for the space station, for the ISS, and So we have an exercise device called ARED on orbit, and you can see one of our astronauts is working out there doing bench presses. And the difficulty is that that lifting arm that he's using, there are times where it doesn't, it needs to stay in a lower location. And so far they've been using kind of Velcro straps. Well, those Velcro straps get worn out, or sometimes they float away, and they're looking for another way to hold these things down that'll be a little bit more consistent. And so there's a separate page that describes this a little bit more so that you can get a better understanding. Make sure you check that out because it has a lot of information about how ARED works, as well as specifics about that area and the dimensions that are necessary there. So that'll be very helpful. So although this may not sound like a really exciting one, this is one that would save the astronauts a lot of time, and there's a lot of interest from both the astronauts and from the trainers here on the ground at getting some supplies that will make this easier for the team. So this is, it sounds simple, but it's a very important bracket that's necessary for improving the astronauts' capability with this ARED. Okay, next one. Also on ARED, there's a cable that keeps getting damaged. Now, that cable is very small, and it's very close to the same Velcro straps that we're looking at, but we don't really understand why that cable is getting damaged. And so we are looking for some kind of a cover that can go over that and be able to make it so that if it's getting bumped, if it's getting twisted or something because somebody is floating by and pushing on it with their foot or something, and we just don't realize what it is, it'll protect it. Now, the part of that difficulty is the crew has to be able to inspect it. So it makes a requirement that either you make it out of a transparent material, or you make it out of a substance so that you can kind of flip it back quickly and easily and be able to see that that cable is or is not damaged. But so there's some interesting challenges to this one. Now, this one could also be very simple. It might be a clip that you put on there that just covers it, but you still have to be able to have the range of motion that this cable requires. And again, this one could save the astronauts a lot of time. For every hour of astronaut time that we have on orbit, it costs somewhere on the order of $150,000 potentially. That's a very expensive thing, just because we would really like them to be doing experiments and doing work on the space station. However, it takes a lot of people on the ground to be able to support anything that's going on orbit. So the less maintenance that we can do, the more we can have the astronauts doing the jobs that we really want to do. Okay? So this is also a very important and very, very valuable bracket that could save a lot of time for the astronauts. Okay? Next slide, please. Oh, and this one also has another presentation to help give more detail about that area. Okay, on the collapsible sleeping quarters, this is also a very exciting one, just because this is not necessarily for the International Space Station, but for some of the next vehicles going up. So this would be a sleep station that might be used on the space station that would be orbiting the moon, and potentially someplace that you would sleep if you are trying to get off to Mars for another mission. So this is something that could be pretty exciting. And again, there's another presentation to give more detail on it. So the idea is that when this new space station goes up, it won't be able to have the sleep stations already in location. And so we have to be able to take them up in a much smaller vehicle, remove them from that other vehicle, and transfer them into this new space station, and be able to kind of inflate or assemble them on orbit. Now I've put a couple of ideas of how you might be able to have a flexible cloth or a plastic material that would expand into the new sleep stations. Some of the things that you want with a sleep station, though, is a little bit of privacy, so that maybe you can read a book without hearing all of your partners. Maybe you can talk to some of the people without talk to somebody on the ground without everybody listening in on your conversation. And you're not going to get that with cloth, but there might be things that you can add to this sleep station, like bags of water, or you might have other things that you can take with you that are going to give you some of those other options. So I think that there's a lot that can be done with this. This is a difficult one, just because not only are you trying to supply a place to sleep, it's a little bit more than a sleeping bag, because you need to have a light in there, and you also need to have a fan to help blow air into and pull air out of this sleep station. And so you'll have pockets for personal supplies, and maybe on the outside for stowage of some kind of radiation protection. And then you would have to have openings for lights to get in there, for fans to be able to blow air around. So this could be a very complicated one. And the challenge is to see how simple you can keep it. Okay? All right. Next one, please.
So Glenn, we're going to stop the recording, and
Okay.
I'm going to send another invite out